In this section, I'm going to talk about some of the memory functions that are part of the string.h library. Now, some of these functions are actually quite similar to the functions we have seen in previous sections, and so I will really not take a lot of time going through them. The functions in this section can be used to handle strings, but can really be used to handle data structures of all types of data types. And for that reason, in the discussion, some of the discussion that will follow, blocks of data are referred to as objects, not strings. And that will become very obvious right here. So let me quickly walk you through the broad functionality of each of these functions. So memcopy is a function that will copy a specified n number of bytes from the object, from the starting location pointed at by S2 into the location pointed at by S1. Now, the first thing that you'll notice is that we are no longer talking about character pointers. Instead, the pointers that you see, not just in this function, but subsequent functions, are void pointers, meaning that the underlying object, the underlying data that's being copied here, does not necessarily have to be characters, can be integers, can be really any data type, even structures. So that's why I said that these functions are even more general purpose than the functions we've already seen. Nevertheless, we can still use them for strings. So whenever we are talking about objects over here, you can imagine each such object to be a string. The size that is being specified here in memcopy, for example, is the size in bytes, kind of like the size in characters, because each character is 1 byte in size. We have one slightly different function over here called memmove. Mem is short for memory in all these function names. Move is obvious. So obviously you can copy data or you can move data. And memmove is different in the sense that it copies n bytes starting from the location pointed at by second argument pointer, void pointer S2, to the location pointed at by first argument, void pointer S1. Memcompare compares the first n bytes of the memory location starting from the location pointed at by void pointer S1 to the contents in the memory location pointed at by void pointer S2. And the return type is similar to what we saw in the string comparison functions. This function returns 0 if all the bytes match, are equal, less than 0 or greater than 0 if they're different. You can also search for a byte in a block of in an object using the mem character search function. So this one will locate the first occurrence of C, the second argument, in the memory block starting at pointed at by void pointer S, and it will do so up to it will perform its search in the first n bytes. And then we have the mem set function. This one is also slightly different from what we've seen before. This one copies, n instances of the byte specified in the second argument into the location pointed at by the void pointer in the first argument. An example will make this function quite clear. So I'm going to go less into the description over here, but remember about void pointers. Void pointers can be used to manipulate memory of any data type. And also remember that you can that a pointer pointing to any data type can be assigned directly to a pointer of type void. And the reverse, a pointer of type void can also be assigned to a pointer of any other data type. So these functions can be used for data of any type. So let me just jump directly, since I think you already understand what these functions do. Let me jump directly to the examples. So over here, memcopy, we have a character array S1, size 17, and we have another character array S2 containing this string, copy space this space string. And we use the memcopy function to copy the contents of S2 into S1, and we do that for 17 bytes. And we print out, so after we do that, we call the printf function. We print out this string after S2 is copied into S1 with memcopy. S1 contains, and then we print out S1. That's what's happening. And when we print out S1, this is what we'll see. Copy this string. Memmove moves the contents from one location to another. And here's an example of that. So we have a character array containing this string initialized to home sweet home. And we print out the string over here first. It's constant string, the string, and array x before memmove is, and we print out x, and that should show home sweet home. And then we print out the string in array x after memmove is, and look what we're printing out over here. We are moving the string beginning at the 5th memory location of x. So which one is that? 0, 1, 2, 3, 4, 5. So starting at the capital S, from here we are moving 10 characters to the start of the same array x. So we're moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sweet home, we are moving that to this location. So this will overwrite home space sweet will be overwritten with sweet space home. And the final string will be sweet home, and the home from before will be untouched. Sweet home home. Message doesn't make much sense, but I hope it clarifies what the memmove function is doing. Then we have the memCompare function. That's pretty straightforward stuff. So we have, again, two character arrays, one S1, one called S2. S1 contains uppercase characters A, B, C, D, E, F, G. S2 contains uppercase characters A, B, C, D, X, Y, Z. And what we're going to do, so obviously the first four characters in both strings are the same. What we're going to do is we're going to call, so we're going to print out S1 and S2 first. And then we're going to call memCompare on S1, S2 for the first four characters. And as you can see, A, B, C, D, those match up. So the result from memCompare is expected to be 0 for that, because the first four characters of both strings are equal. Then we call memCompare for all 7 characters, and that's of course when we'll see a mismatch in the last 3 characters. So compare S1 to S2. The answer should be -1, because S1, the first argument, is the string that comes first in the alphabetical ordering. So the result will be -1. Swap the order of the 2 arguments, and we should get +1. And that's what you get in the output. So this is again very similar to the, almost identical to the string compare functions we saw earlier. Then we have the search function, the equivalent of the generalized version of the character search function we saw just earlier, memCharacter. So searches for the first occurrence of a byte, represented as an unsigned character, within specified number of bytes of an object in the first argument. If it's found, it returns a pointer to that byte location. If it doesn't find that byte within the search space, within the search region, a null pointer is returned. So let's say in the next example, we'll have this string. This is a string, and we'll search for character R in that. R appears over here. So the return value should be a pointer pointing to this location in this string. Or I should say, in that object. So we have a constant character array S, a pointer to a constant string. This is a string, and we print out. So we call memCharacter. We search for the letter R in the first 16 characters, starting at the starting location of this pointer S. We'll find a match at this R, and we print. That's the return value from this function, which we are printing out. And this will print it out as a string starting from R all the way to the end of the string where we have a null character. So this will print out the word ring. And then we have the memset function. This one is also slightly different from what we've seen before. It also does copy. It's also used for copying stuff. Has an interesting use. So the memset function copies the value of a byte that is specified as the second argument into the first n bytes of the object pointed to by the first argument. And n is, of course, the third argument that you provide to this function. In the example, we're going to copy the character B into the first 7 bytes of string 1. We'll be overwriting the first 7 bytes of string 1 with B. And here's what that looks like. We have, let's say, a 15-character string containing all capital Bs, even printed out. And then we print out string 1 again, but this time we call the memset function on it first, and we overwrite the first 7 bytes with a lowercase b. And when that prints out, that will change string 1 from what it was here to this. You can see the first 7 b's are lowercase b's. I want to show you just one more function, and I'm going to skip over some stuff. And that's this, the string length function. What it does is it takes a string as an argument, and it returns the number of characters in the string. Basically, it counts the characters until it encounters and finds the first null character. And it takes that as the length of the string. Simple example for that. Let's create 3 constant strings and define 3 pointers to them, string 1, string 2, string 3, and initialize them to these strings. So the first one, that's the 26 letters of the alphabet, English alphabet, lowercase, the word for, the name, city name, Boston. And these strings have different length. They're all terminated by null characters, which we don't see. And what we're doing in the printf statement right below that is we are passing string 1, then string 2, then string 3 to the string length function. And we do that, and we also print out the strings, of course. And what we see is this. For the output, the length of Z string is 26, the number of letters in the alphabet. The length of 4 is 4. The length of Boston is 6. So string length function, very simple, but also can be very handy at times. And that completes our study of strings and string manipulation, various string functions. And we'll move on to our next chapter next time.